So we tend to do things where we look at things graphically through a table and algebraically. With differential equations, the last couple of videos we're looking at it algebraically. For this video, I want to look at it graphically. We can graph the general solution to a slope field or to a differential equation, which sounds weird because there's an infinite number of solutions to a differential equation because of the plus c. Plus c is any constant. So how do we graph something that can be an infinite number of possible constant values for the plus c? And this is where the slope field comes in. What it is it's little tiny pieces of tangent lines where at whatever coordinates that little piece is at, it's showing this is the slope of my function at this point. So we can use this as little ways of kind of directing us on how to sketch particular solutions within a slope field. So here I've got a picture of a slope field for the differential equation dy dx equals 2x plus y. If I were to say, well, my initial condition must go right here, I can follow these little pieces to see, oh, that's what my particular solution would look like. Or if I put it right here, I can follow the little pieces and I can see an idea of the general shape of my solutions. Oops, not sure why it disappeared like that. I do need to put arrows on the ends of those because they do keep going. And these are sketches. They're not meant to be perfect, they're sketches. Slope fields look intimidating to make, but they're actually not that hard to make. I actually really enjoy drawing out slope fields. Because all it is that we have to do is we take each coordinate point, plug it into dy dx, and see what's the slope. So here, we're going to make a slope field for dy dx equals 2x. And after that, we'll sketch a particular solution that goes through point 1, 2. So I'm going to just pick a point like 1, 1. At 1, 1, oops, dy dx, well, I plug 1 in for x, I get 2. So I'm going to draw a little dash that has a slope of about 2. It doesn't have to be perfect, but it should look like it has a slope of 2. Whereas if I went to 1, dy dx, plug in 2 for x would equal 4. I need it to look steeper than where it was a slope of 2. Again, it's not a perfect 4, but it should look better than as I go from a slope of 2 to a slope of 4, I should see it steeper. You know, if x is 0, I have a slope of 0. If x is -1, I have a slope of -2. If x is -2, I have a slope of -4. And the nice thing is because I only have x's, that means everywhere x is 0, the slope is 0. So I can fill in my slope field rather quickly with that. Everywhere x is 1, the slope is 2. Everywhere the slope is -1, the slope is -2. Everywhere x is -2, the slope is -4. And where slope is +2, slope is +4. And there is my slope field for the differential equation dy dx equals 2x. If I then want to sketch a particular solution that goes through the point 1, 2, I think of these little lines a lot like directing how a ball rolls, and I want to have the ball roll both directions here. So as I go towards the right, this is saying, well, I need to be going up, and as it goes up, it's going to be going over, and I can see it's going to have to get steeper as it goes over. It's not connecting the dots. The little lines just give me directions that I should be making my sketch curve in. I'm not connecting dots. I do need to put the little arrow on the end to show it does keep doing that even past where I can draw it on the graph. As I move to the left, it's going down, but it starts flattening out. It has to have a slope of 0 when I cross the y-axis. And then it starts going up again and getting steeper as I move to the left. Again, I'm not connecting dots, not intentionally. I'm just getting it to using the dashes to get an idea of how I should be curving up and down, steeper, less steep, etc. And again, I need arrow on that other end to show it keeps going on forever. So the blue is my slope field, which is a graph of the general solutions. The red is a sketch of a particular solution.